Good morning, folks. Instructor Gaynor here. We're talking a little bit more about some of those fallacies related to inductive errors. And again, these are informal logical fallacies that we're going over. We had talked about the concept of hasty conclusion / hasty generalization already. And the next couple of the ones I'm talking about could loosely fit under that broader heading of hasty generalization. So I'm going to ask you, like as I have in the past, when you're trying to spot fallacies, do your best to find the one that most specifically identifies what's wrong with the argument that you're observing. In other words, get as specific as possible. Now to move on. The next two fallacies on our list pertain to sampling. Now, when we're talking about sampling, folks, think statistical sampling. Now, this is not discussed in the textbook, but I think it's kind of important to understand the larger context. When we're trying to draw generalizations about a larger group, you might hear this larger group that we're trying to draw a conclusion about. You might hear it called the target group. Now, the reason why we call it the target is because that's what we are targeting to make a generalization about. Now, suppose that our target that we're trying to draw a conclusion about is the community of all of our college students. Now, all of the college students that we have are a diverse bunch because we're a multi-campus college. So in other words, our demographics are fairly diverse. Now, if we're trying to draw a conclusion about the opinions of our college's students, what we would do is we would take some kind of survey and we would sample. And by the way, the sample group that we would be surveying would be a subset of the target. And if you don't like this semi-mathematical lingo, I apologize, but it's probably the best way to make sense of it. So whenever we're taking a sample, that sample has to be a component of the target group. Otherwise, we won't be able to do what? Draw any conclusion about the target group because the group that we'd be surveying would be irrelevant. So when we're talking about sampling, we're talking about statistical sampling to try to draw a conclusion about the viewpoints, etc., of a larger group. Now, folks, there are two fallacies in this textbook that are related to sampling biases, as some textbooks call them. The first one on our list is what the author calls small sample. Now, unsurprisingly, folks, when we have a small sample, and this is going to sound so darn circular, a small sample occurs when the sample population that we have taken is insufficient for drawing a conclusion about the target. Now, students frequently ask, how sufficient is sufficient? In other words, how do I know if I have a large enough sample size to draw a conclusion about the target? Now, simply put, there are sampling generators on the internet. So you don't have to be a statistician in order to figure out whether or not a sample size is sufficient or not. Now, folks, if you know roughly how large the target population is, a statistics generator can tell you how large of a sample that you have to take in order to get a reasonable margin of error. And ladies and gentlemen, there will always be a margin of error. Because remember, folks, Statistical sampling is an inductive process. And as an inductive process, we cannot have quote unquote certainty. However, if our sample size is sufficient, we can have reliable statistics. Now, there is something that the author of our textbook does not address. And this is something I need to talk about, because when students are asked to go out and find fallacies out there in the real world, very frequently, they will go to some survey or another, and here's an example of what I tend to get. A student will look at, say, a Pew Research Center poll or a Gallup poll, and they will say they only surveyed 1,100 people. How can 1,100 people be sufficient to represent, say, the opinions of all Americans? Well, guess what? Statistics actually has an answer for why that is actually a sufficient sample size, even if it seems counterintuitive. And I'm going to send you my little write-up on this in case you're interested. There is something in statistics called the law of large numbers. Perhaps some of you have heard about the law of large numbers. Now, I am not going to run through the demonstration of this law of large numbers. As a matter of fact, it's not terribly complicated, but it does indeed involve the statistical calculus. Instead, I can explain to you what it means and why it is so. Now, folks, what the law of large numbers concludes is that as the target size starts to get larger and larger, guess what happens to the size of the sample relative to the target that you'll need to represent? It goes down. It goes down as a percentage of the target. So in other words, let's say our target population is in excess of 1 million. It would be perfectly sufficient to survey under 1,000, and you would still get a plus or minus 3 margin of error. And this has to do with a concept that if you've taken a stats or a calculus class, not required here. How many of you remember these things called limits? You say, take the limit up to infinity. Well, guess what? 1 million is not infinity, but it's what? It's getting pretty darn large. This is why, if your target population gets very, very large, the percentage of that target that you need gets smaller as a percentage of it. And if I can use plain English to also explain why. The larger the population that you sample, the more you will minimize this group that we call this. The more you minimize the significance of what we call outliers. Outliers is just a phrase for those data points that are outside of the norm. This is why if your target population is in excess of 1 million, it will be sufficient for an organization like the Pew Research Center to sample maybe 1,100 people. And it would be statistically sufficient, provided there are not other errors made by the study. Now, let me give you a couple of examples that are of insufficient sample size and also of relatively small target. Do any of you folks work in the service sector, like restaurants? Anyone worked in restaurants? Back in my day, before the internet got big, we had these things called comment cards at the tables. And we were encouraged to hand out comment cards to as many of our guests as possible. Now, at the end of the night, typically you may have only gotten a handful of people willing to hand in those comment cards. Let's say that you did 150 tables in a night at a decent sized restaurant. Would 5 comment cards being handed in be statistically significant? The answer is no, because 150 is actually a fairly small target. So you're going to need at least 10 to 15% of the clientele to fill out comment cards in order to have a statistically significant sample size. Because if you don't, take a guess whose significance will be too high. Outliers. Because the outliers are the ones who are, in many cases, more likely to fill out the comment cards. People who are very, very pissed, and or people who are very, very satisfied. So you might actually overrepresent the outliers unless your sample size is large enough. Johnson.
So you're saying, like, if you were to say take the IQ of say 5 people, one of them had a really high IQ, and you said 20% of people have a really high IQ, and that would be fallacious.
Yeah, because you would have to, if you're trying to talk about all Americans, you would really need you'd need at least 1,000 people. Now, for many people, they'll think, well, 1,000 doesn't sound like a lot. Well, because of the law of large numbers, it would be significant enough to get a plus or minus 3 margin of error. It would be significant enough to get a plus or minus 3 margin of error. Now, I can come back to this in a few minutes. What I wanted to talk about next, folks, is what the author of the text calls unrepresentative sample. And I want to make a snide remark here. Insofar as something is a small sample, guess what fallacy it will pretty much always also commit? Unrepresentative sample. It will be unrepresentative because it will oversample or outliers most likely. Now, what is an unrepresentative sample? It occurs when the sample population that we've taken is insufficient for representing all of the sub-constituencies within our target group. Because our target group that we're trying to draw a generalization about will seldom be homogeneous. In other words, it will be made up of a wide variety of people in various subgroups. So if you only sample, like let's say we were trying to do a survey about hack students, but we only surveyed people from one of the campus locations, we would have an unrepresentative sample unless we were able to demonstrate sufficiently why one campus group is representative of all of the different campus constituencies. And I can tell you why it would likely be unrepresentative. Because the demographics of our exclusively virtual campus students tend to be different from our students who take exclusively face-to-face classes. The demographics of our students who tend to take evening classes exclusively tend to be different from our students who take exclusively daytime classes. So in order to actually represent all of the subgroups, we would have to find a way to make sure that members of each of those subgroups were, in fact, represented. How would we do something like that? Well, exactly like a big research organization would. We would use something like ID numbers, and we would randomly send something like an email to every 10th student, or some similar number, in hopes that we might be able to get 20 to 25% of the people who those emails were sent to actually fill out the survey. Now, the reason why we would have to send out more surveys than the actual number that we would need to be sufficient to represent and sufficient for size is because you have to bank on the fact that a lot of people will do what? Yeah, won't answer it. In other words, no response. You have to figure that in. This is part of why whenever I see some kind of conclusion being drawn based upon a statistical sample, and they only tell me the number of people that they sent surveys to, I get a little bit suspicious because I don't want to know how many surveys they sent. I want to know how many responses that they got. And I also want to know that the number of responses that they got is statistically significant enough to represent the entire target population. So in order to, and I'll wrap something up here, in order to figure out whether your sample size is large enough and whether or not it is likely to be representative or not, you at least have to have a rough idea of how large the target is that we're trying to represent. And you also have to have some idea about the methodology that was used in order to gather the sample population. Because otherwise you can't be certain if enough surveys were taken, and you also cannot be certain whether or not the methods were effective for getting a representative sample. Is that fairly understandable, I hope? I wanted to talk about these two fallacies together because they are indeed intertwined with one another, because both of them address the issue of problems with sampling and trying to draw a conclusion about a larger target population. Now, let me give you one more little example before we leave this. We frequently see these news organization posts, and they will say CBS News poll or Fox News poll, and you can look these kind of things up online. I am sometimes suspicious of such surveys if they are voluntary surveys. Why? Because if there are people who volunteer to fill out a survey, you might be getting a large number of outliers rather than actually a real cross-section of the population. So keep in mind, if the demographic that's filling out these surveys happens to be of a like mindset, you ought to be suspicious about generalizing their opinions to the opinions of the general population. Because the group that you're surveying has to be significantly similar to the totality of the group. Is that pretty clear? Yeah, Johnson.
So how do you make sure you get a group, or your sampling method is representative of your group?
Well, survey organizations will find a way, and I'm glad you asked. And the text fails us on this point. I hope I'm clear about this. You have to find a way to make sure that your sample group is truly random, or at least close to random. Now, what is a mathematical definition of randomness? Yeah, if a sample is truly random, it means that every single member of this target group has an equal likelihood of being selected for the sample group. That is what randomness means. That every single member of the target group has an equal likelihood of being selected as part of the sample group. Now, the reason why sampling has to be random if you want to get a truly representative sample is because if you don't, you might be oversampling certain subconstituencies and undersampling certain other subconstituencies. This is also part of why organizations that have an axe to grind, who use self-selected samples, those kind of surveys are always problematic. Because if you know what the population is who you're giving to the survey to, there's a good chance you already know exactly how like-minded people will respond to a survey. And then if you take that group of like-minded people and say, hey, America has spoken, but wait a minute, you only sampled NRA members. That's not America, that is a subset of Americans. Or hey, you only surveyed members of the Catholic Church. Well, wait a minute. That's only a subset of Americans. You can't draw a generalization about all Americans if you're only surveying one sub-demographic. And this is, of course, when political parties survey their own members. They better darn only be drawing a conclusion about members of their own party. If they try to generalize about Americans in general, there would be a sampling problem, a representation one, because they only sampled one particular demographic rather than a demographic that represents the entire target. Have these examples helped, I hope? By the way, reputable polling organizations typically do a very good job of trying to make sure that they have a significant sample size as well as a truly random sample. And by the way, most of the time, reputable polling organizations actually have the resources to do it, because it actually does take a lot of homework to make sure that you get this done. Johnson.
Yeah, if you sample random media, isn't it possible that you could end up with a large percentage of a certain people and just not know it?
Well, you could, but generally speaking, that tends not to happen. Because if your sample size is large enough, if it's random and large enough, it will take care of that problem. It will take care of that problem. To a margin of error, of course. To a margin of error. Now, conveniently, folks, since we're talking about polling and sampling and things of this nature, this is probably a good time to talk about two other things on the fallacy list, even though they're out of order. Folks, I am going to ask you not to use this sample name unless you can't find anything more specific for it. It's what the author of the text calls questionable statistics. Questionable statistics refers to a case where an argument is based upon some kind of statistics or other. And when you have concerns over the accuracy of those statistics. If you don't know how the statistics were gathered, if you don't know when they were gathered, the circumstances under which they were gathered. In other words, if there's all these nagging questions as to whether or not you can be sure that the statistics are reliable or not, then you have something like a case of questionable statistics. The author also has a category that is referred to as questionable use of good statistics. Now, unsurprisingly, this is a situation where you have sufficient reason to believe that the statistics are likely good ones, aka reliable ones. However, the arguer is using the statistics to draw a conclusion that really does not follow from those statistics. So this is the case where the problem isn't the statistics. The problem is the kind of conclusion that the author of the argument is trying to draw from it. In other words, it does not follow, even if the statistics are true. Now, some of the ways that this can happen is if the statistics are really unrelated to what the alleged conclusion is. And guess what you may have to do in order to uncover that? You may have to read the thing very carefully to determine whether or not these statistics are relevant to us drawing said conclusion. Finally, the author talks about another thing related to sampling. And all of these are kind of not in order with one another in the textbook, but I'm handling them together because they're related, and it's kind of convenient to have them all in the same little lecture extract. This last one I'm going to talk about is what the author refers to as a special case, poll questions. Now, the point that the author and I'm going to be making right here is probably quite obvious to all of you. When we draw conclusions about sampling groups, one of the tools for getting information is to ask survey questions. Part of determining whether or not the statistics about what that group thinks are reliable or not is determining whether or not the poll questions are effective instruments for doing so. There's various ways that poll questions can perhaps get us biased results. What I'm going to talk about right now is illustrated in the practice problems, which I know that you'll see some of these cases in the practice problems. We will also revisit this in another chapter when we discuss the persuasive use of language. My long-winded point is, the words that you use within your question may actually bias the results of the question. Or to put it another way, the linguistic framing that we use, have anyone heard this phrase, linguistic framing? The words that we use have a lot to do with the way we see reality. The very words that we use in our poll questions might influence the way that people are likely to respond to them. Now notice, if we talk about our government health care proposal as universal health care, there's a good chance there might be a fair number of people who say yes to it. If we frame the very same proposal as socialized medicine, there's a good chance that we might get the opposite results, decidedly negative ones. And this is because of the powerful negative framing of the word socialism in the United States over the last close to a century. Sorry, I fumbled there, but yeah, close to a century. As a matter of fact, socialism has had a bad name among most Americans since the first Red Scare. Many of my students don't know what the first Red Scare was because of them not learning about it in the high schools. I'm talking about during the administration of President Woodrow Wilson. That was the first Red Scare. Very frequently, my students only heard about the second Red Scare. But yeah, so this is why if you want the public to be against something, simply use the S word, socialism, and there's a good chance they will be against it no matter what the details are. Or go further, call them communists. And they're likely to be against it regardless of the proposal. Now let me give you a real life example. When the Affordable Care Act was framed in terms of its actual details and some of the positive things that would come about as a result of it, large numbers of Americans actually said yes to it. They said that it was a good thing. But when you change the framing of the Affordable Care Act and called it what? Obamacare. The phrase Obamacare was intentionally constructed by opponents of the Affordable Care Act because of the connotations of calling it Obamacare, because their constituents tended to hate Obama anyway for one reason or another, and I'm not giving any opinion one way or another there. But if you already have negative views about the president, no matter what you say next is likely to not matter because they'll be against it. Now, when I heard Obamacare as the phrase that even supposedly left-leaning public radio was using that framing, that told me that the Republicans actually won in the public sphere there, because their linguistic framing was the one that the mass media was using. When I hear Obamacare, this is what I always heard. It is this evil dictator Obama wanting to force this down our throats. That is why they called it Obamacare. It wasn't Obama who called it Obamacare. It was the opponents who called it Obamacare. And of course, Obama, and some of you might remember this, some of you might be too young, oddly enough, or maybe not oddly enough, I'm just older. But anyway, his sort of, I guess, funny quip with that is he did, I am Obama and I do care. You know, that was, his sort of, yeah, I do care. Unlike perhaps some of my, opponents. That was sometimes trying to make light of a bad rhetorical situation might be the only thing you can do. Now, a couple other things about poll questions. Sometimes what you don't put into the poll question is just as important as what? What you do put into the poll question. In other words, if you selectively put certain information into the poll question and you exclude other important information, you might be shaping the way that the people are likely to respond to it. Now, some other strategies for biasing polls in various ways has been to give people a pile of information, self-selected information, and then ask the question. In other words, you give the people this information that's likely to steer them one way or another, and then you ask them the question. Well, guess what? If the people didn't know much about the topic ahead of time, and then you give them your information about it, there's a good chance they're going to answer the question the way that you have set them up to answer it. So please don't treat those kind of polls as if there's any objectivity to them, because there's not. One more thing, and I hope I'm not going overboard on this too much. One other thing. I am always skeptical about polls that only give me how many choice options. 2, do you agree or do you disagree? Well, guess what? There's a range of different positions that you might take on this. Strongly agree, somewhat agree, neutral, somewhat disagree, strongly disagree, don't know. Because in fact, in many situations, maybe the don't know option should be there. And by the way, folks, we'll be talking about psychological impediments to cogent reasoning in an upcoming chapter. But do keep in mind that people are sometimes uncomfortable if they don't know much about a topic, and then they are asked to answer questions about it. Sometimes they might answer questions about something that they don't actually know much about. So this is part of why, having things like don't know options, I might even add the don't care option. Because indeed, finding out that a large number of respondents don't care might actually be relevant too, believe it or not. Now, of course, you could probably have too many options to be easy to tabulate. But yeah, the hope is to try to find some way to actually get meaningful and accurate results. from your poll. That is provided that that's actually what you're trying to do. Because in many cases, poll questions are typically, used to get some conclusion that you already want. So then you can use it as propaganda in a campaign. That's not a good poll. That's not an objective poll. But indeed, it is one of the objectives that polls are sometimes used for. How many of you have heard of so-called push polling? When somebody calls your house during a political cycle, and they say, hey, I want to give you a survey about your opinions on this candidate. No, they really don't want to give you a survey. What they want to do is they want to talk at you for a couple minutes under the guise of a survey so they can plow you full of information. That's another one of these uses of polling. Keep in mind, polls aren't always just about gathering data. Sometimes they're used for these, propaganda aims, for lack of a better word for it. Unfortunately, I'd like to continue, but we are out of time. My apologies.